welcome back to another video. This video is going to focus on a Cayley question, which is from 2010, but it's very similar to what you'll see in the Senior Maths Challenge. So let's have a look at the question itself. A square sheet of paper, which is A, B, C, D, is folded along FG. And can I just say something about the way that it's labeled, because that's going to be addressed at some point and not in a brand new video. See A down there, that is the first letter, and when we think about labeling a square, it's really important to stick with the order either clockwise or anti-clockwise. So you can see that A goes to B, which then goes to C, which then goes to D, and it's not chopping and changing. So the corner of B, which is down the bottom right, is folded up to meet the midpoint. And you can do this in real life if you want. But you can see it used to be down here at B, and it was folded up like that. Now it says that that is folded to the midpoint of CD. And we have to prove that the sides of the triangle GCM, that's the top right, have the length of ratio 3, 4, 5. The alarm bell's ringing straight away. 3, 4, 5, that's Pythagoras, right? That's the Pythagorean triplet, the base. So it would be interesting if we could find out some expression for those sides. And it might be something to do with Pythagoras. We know that if there's proof with Pythagoras, in other words, Pythagoras' theorem is trying to prove something, then Pythagoras' theorem should hold. As in, we put the numbers in and we should find that ratio. Okay, so we'll have a quick look at the beginning now, because this is where we're going to get most of our information from. The skill that we're looking to introduce for you today is not doing the question, it's part of the question. And that is adding letters where appropriate. So if we think about this whole square, do we know the point where G is folded up? That's this point right here. Do we know how far that is? Is it the midpoint? There's no way of telling. What we can tell is that M is the midpoint. This one here is definitely, because it says in the question. And so we can just give that particular length a letter, which would be useful to use. We'll give this top length between M and C the letter X, but X will now represent any halfway point around the edge of this square. Now, since G has been discussed to be not known whether it was the midpoint or not, we'll give it a different letter so that we can work with it. What a different letter? Well, this side here, because we're going to need to use that in proving something about the triangle GCM. Another thing we know, this is a right angled triangle. This is definitely giving weight to the fact this might be Pythagoras, Pythagoras' theorem coming up. And finally, what do we know about M to G? Have a think. Yeah, you could go ahead at this point thinking that, okay, I've got Pythagoras, so what does that mean? We could do x squared plus y squared, and then that's going to be equal to mg squared. Okay, useful. Not massively useful, because if we're trying to prove that these have a ratio of 3, 4, 5, we need to write all of these three in terms of each other. So we need to think again. How can we think about the distance M to G? Well, let's look back at what it was when M was down at B, okay, before it's folded up. That point, that whole side, which is the same as the side A to B, is equal to 2 lots of those x. And you know, A to B was just the easiest one to see. That's also true of B to C, which is the part we're interested in. And what do we know particularly about the length that was folded up from B to G? We know that if we took 2x which is the whole length, and we take away the y, that's going to leave us with this bit here. And this particular bit is m to g. So we have mg. And we're going to label it onto the diagram. Now, the purpose of this video is not to complete this particular question, but we've heard Pythagoras' theorem enough here. We've seen ratios, we've seen sides, we've seen that it's a right angled triangle, and a 3, 4, 5 is a triplet. And so we've got enough here to say, you have a go, finish it off, and see if you can prove that they have the ratio 3, 4, 5. If you'd like to see the solution to this question, then leave a comment in the comment section below and I'll make a video.